In the intro to lesson 5.4, you will learn how to graph compound inequalities. A compound inequality contains at least two inequalities and is separated by either and or or. The graph of a compound inequality with the word and represents the intersection of the two graphs, or the overlap of the two graphs. A number is only a solution to the compound inequality if it's a solution to both the inequalities. If you were to think of this like Venn diagrams, if all the numbers in this yellow circle are solutions to the first inequality, and all the numbers in this blue circle are solutions to the second one, the intersection of the two inequalities is the green part in the middle. Those are the numbers that are in both, or a solution to both the inequalities. That's what we're going to look for when we graph the compound inequalities with the word and. We're looking for the overlap. It would be like the green part in this Venn diagram. For example, if we wanted to graph x is less than 3 and x is less than or equal to 5, we're going to first go ahead and graph x is less than 3. So we would go on the number line to the number 3 and put a circle. We would not color in this circle because it does not include 3. And we want all the numbers that are less than 3. All of the numbers that are less than 3 go this way. And then we would graph the second one. X is less than or equal to 5. I would put a circle on the 5, and I would color it in this time because it can equal 5. And I want the numbers that go to the left because I want all the numbers that are less than or equal to 5. Now, if I were to graph the compound inequality, these two together, the numbers that are solutions to this inequality and to this one, it would be like taking this graph and putting it over the top of this one. And where they overlap, that would be the solution to the compound inequality. So the solution to this compound inequality, where they overlap, is starting at the number 3, but not including 3 because this is not filled in. All the numbers to the left. So if you visualize the first one on top of the second one, the place where they overlap, that's the intersection. Now, you will not see this in our textbook, but oftentimes you may come across intersection using this symbol right here as well. They would write this one with this symbol in between, and then this inequality instead of the word and. This stands for intersection as well. In the second example, this is another way where you can write an inequality that would be with the word and. This inequality is -2 is less than or equal to x, which is less than 4. If you wanted, you could break this up into two separate inequalities. Just this piece right here, if I were to write that one, it's x is greater than or equal to -2. So I'm just looking at this part, and I wrote the variable first, so x is greater than or equal to -2. So I'm going to put an open circle on the -2, and then I'm going to fill it in because it can equal -2. And then the ones greater than it will go to the right. Now the second half of this problem is right here. X is less than 4. We would put a circle on the 4. We would not color it in because it doesn't include 4. And then the numbers to the left are this way. Or the numbers that are less than 4 are to the left. Now if you were to graph the intersection of these two inequalities, you're going to take your first one and put it on top of your second one. And you want just the parts where they overlap. So they overlap from -2, and it includes the -2 since -2 is the solution of both. And it goes all the way up to the 4 but does not include the 4. So it's going to be this section right here, all the numbers in between those 2 points. So those two examples show an intersection, or ones with the word and. If you put the one graph over the top of the other, it's where they overlap. The second type of compound inequality is with the word or. The graph of a compound inequality with or is the union of the two graphs. A number is a solution to the compound inequality if the number is a solution to at least one of the inequalities. It doesn't need to be a solution to both. So in this case, if I were to think about a Venn diagram, here are all the numbers that are solutions to the first inequality. These are all the numbers that are solutions to the second one. And the solution to the compound inequality is this whole thing. It is all the numbers. It can be in one or both, it doesn't matter. So if I were to graph x is less than 3 or x is less than or equal to -5, I want to graph each one. So x is less than 3, I'm going to put right here. X is less than 3 will be an open circle on the 3, and it will go to the left. And then if I want x is less than or equal to 5, I would have a filled in circle on the 5, and less than or equal to 5 is this way. Now if you were to visualize putting this graph on top of the second one, it's not just where they overlap, it's anything at all that's covered by either one of the graphs. So the solution is going to be all the way over here on the 5 and including the 5 all the way to the left. All of the numbers that are less than or equal to 5 is a solution to this compound inequality, because the solution can be a number that satisfies this one or this one. It does not need to be in both. It can be in one or the other. Our last example, graph x is greater than 3 or x is less than or equal to -4. Well, x is greater than 3 is going to be an open circle on the 3. Greater than 3 is going to go to the right. Now for x is less than or equal to -4. Filled in on the -4, and it goes to the left. Now if I were to graph the union of these two, I would visualize the two graphs on top of each other. In this case, they don't actually overlap at all. But if I were to graph everything that I see when I lay the two on top of each other, the graph would look like this. I would have a filled in circle on the 4 with it going to the left, and I would have an open circle on the 3 and it goes to the right. So the union of the two graphs, or when I put the two graphs together, it looks like this. Now, just like there was a symbol for the intersections, the symbol for a union looks like this. You won't see that in your textbook, but you will possibly encounter it in a future textbook. So I just wanted to point that out.